which I don't go into for now. Okay, with the zip list we had this impact figure on the throughput. So I decided to do the same for the insets, and the impact of on the performance is much lower here than with the zip lists. The reason for this is partly because the integers are fixed with and very small. So when you have 10,000 element inset, it only occupies 80 kilobytes. So yeah, what's 80 kilobytes? It's nothing. So this can scale up to, I don't know. I haven't tested beyond this figure, but I should actually, because I'm pretty eager to know how far the rabbit hole goes, so to say. Okay, so it's a good fit for up to yeah, I don't know, maybe 20K, 50K integers in a single set, and has a reduced memory footprint of about 10 to 15 times. So very good. But then again, what do you do with sets that hold more than 1 million values, more than 1 million integers? So we again introduced or used the hybrid approach, just as with zip lists, where if the size of the set crosses this threshold, it gets converted to a regular set, and you have your original complexity at the cost of more memory. Other things in 2.2, miscellaneous stuff that popped in my head was that we did some improvements on the memory footprint on regular objects when the VM is enabled. For those of you using the VM, this will be a pretty, it depends on your data, of course, but it can be a pretty big win in terms of memory. For those of you using sorted sets, they have a lower footprint as well. So yeah, also exciting times. Then optimizations on the throughput level. I'm going a little bit fast here because I see that I'm taking a bit more time than I expected. On the throughput, there's essentially two things going on in Redis. First, there's the reading of the reply. This is all done via the event loop. If you know that program a bit, it does a read on the socket. It parses all the requests in the bytes that it just reads, and it processes the request. And this is actually where the comment is executed. Then, when the comment is executed, it builds up a reply. And when the socket is writable to the descriptor, it starts writing the response back to the client. So that gives us two spots where we can look for optimizations. Well, the first thing that we took a look at was the response. Because if you do an L range on a list, you want to get the first 500 elements of the list, all these elements have to be interleaved to match the Redis multi-block protocol. And this can take a little bit of time. So what we decided to do was, instead of putting all these elements in a linked list, just copy them in a static buffer straight away. And this yielded a pretty good improvement. Because for 2.2, if you have a 200 element list, these tests were done on my MacBook, so it can be a lot higher on real servers, so to say. If you look at a 200 element reply, with 2.0 you would get around 5,000 RPS, but with 2.2 you get more than 25,000 RPS. So that's more than a 5 times improvement on the throughput front for that particular size. But it's an improvement over the entire range. The other part was the request processing, of course. We revamped the code and took a look at what's necessary, what can be deprecated, etc. It yielded also improvement over the entire line. Less significant, but still pretty good. Then we have the new expiry policy in 2.2. If you use Redis as a cache, you know that if you write against volatile keys, which are keys that have an expiry set, they are deleted. And this was initially done because of consistency reasons. Because if you have append-only file, you have a replication link, etc. And you have expires, timing issues, you have all these things going on. This can lead to inconsistencies, and that was the main thing to avoid. However, in 2.2, we applied a trick, a pretty smart trick actually, I think, and pretty obvious, by the way, to simply feed the lead into the append-only file and the replication link whenever a key expires, and only leave an expiry up to the master. And this allows you to write against these volatile keys, which comes down to something like this. You have a set of online users, you want to keep it in Redis for, I don't know, 10 minutes, and you keep adding IDs, and it doesn't matter, but after 10 minutes, it's expired from the memory. It's removed from memory. Another thing in 2.2 is that we actually have an LRU mechanism for removing volatile keys. So instead of looking at how long does this key have left to live, it looks at what's the last recently used, and that should not be removed from the cache, of course, because if you hit it, you probably need it again. Other things in 2.2 will be Unix sockets. It's trivial code, and it's when you have multiple Redis servers running on the same machine, you can use sockets for a big memory improvement. And credits go out to Taf. We both worked on the same code for a while there, but in the end, I took his code, took my code, took the best things about from both codes and merged it. Still in the private branch, but that will be merged in 2.2 eventually. Then we have list insert, list push x, list rpush x. That's provided by Roby Pointer of Twitter. And for other stuff, you should check out the Git div. Other things that are being worked on now are iRedis, the support for C clients to access Redis from C is pretty limited, and I decided to really design an API that can be used in any sort of context and make it work. It's the protocol parser that's included just reads a stream of bytes and emits responses, so to say, is entirely decoupled, so that can be embedded in any language you want that supports C extensions, of course, and immediately have fast reply parsing for that interpreted language. Furthermore, we're working on memory fragmentation because it can be an issue, it cannot be an issue. There are all kinds of things that need to be investigated. That's also something we're working on, just to let you know. And that concludes my summary of the things that are coming up in 2.2 and the things we're working on. And do you have any questions about it? Yeah. Yes.
Would you have any measures of how Unix sockets improve performance? Because I have the opinion it should improve it quite tremendously if you have a lot of sequential requests.
Yeah. Yeah, that's a good point. I should have included a graphic for that, but I can tell you that the improvement for typical comments that are entirely I/O bound, for instance, a ping or echo or gets that are the overhead difference is insignificant almost. The throughput improvement is somewhere around 50%, 60, sometimes 70. It differs a bit, but that's the range you should be looking for.
I was going to say, we're probably going to do the full Q&A at the end.
Oh yeah,
so
okay.
So Pieter and Salvatore can answer everyone at the same time. So if you maybe keep your questions until then, that way we can get the talk done and then do Q&A for as long as you want to, as long as we have time for. So, thank you very much. We're going to change over now. If you want to grab a sneaky bear or something, you're more than welcome to.